this video, we're going to show you how to make step response RC and RL circuit diagram in Multisim. But first, let us know what is Multisim. Multisim is an electronic schematic capture and a simulation program which is part of a set of circuit design programs. RC circuit.
First, click this button, then find the step voltage from step voltage sources. Go to Basics. You can find resistor and capacitor. And you can rotate it by pressing Ctrl R. Look for the ground from the voltage sources. And connect them. You can change the value of the resistor, and in this diagram, I change it to 0.5 kilo ohms. And for the capacitor, I change it to 10 microfarad. Then double click the step voltage, you can change it to final level, and I change it to 10. And set the step time to 0. And for the rise and fall, I change it to 0.1 nano. And click the stimulate. Click the analysis and stimulation, and look for transient analysis. Then change the initial condition set to 0 and end time to 10 ms. Click output and add the V2, the voltage of the capacitor. Then run.
So this is the transient graph of the capacitor voltage. Press cursor to see the values of the capacitor voltage with respect to time. Calculate the time constant and calculate the 63.2% of the initial voltage and compare it, because in one time constant, the voltage will be 63.2% of the initial voltage. And move the cursor to 5 milliseconds, which is the time constant. And as you can see, the Y sub 2, which represents the voltage of the capacitor, the result is approximately the same as the 63.2% of the initial voltage. And multiply the time constant to 5. Move the cursor to 25 milliseconds and check if the resulting voltage is more than 98% of the initial voltage. And based on what we see, it is more than 98%. Let's check the current of the capacitor. Click Analysis and Stimulation and look for Transient Analysis. Go to Output and add IL. Let's check if the 36.8% of the initial current of the capacitor and compare it in your cursor if in one time constant, the value of your current will equal to the 36.8% of the initial current. And as you can see, it is approximately equal.
RL circuit.
And now let's make a step response RL circuit diagram. First, click this button and find step current in signal card sources. And then find a resistor. I use two resistors in this circuit diagram, and also inductor, which is parallel to 1 kilo ohm resistor. And for the ground, you can locate it in these sources, power sources. So here is the ground. And connect each terminal. So this is my circuit diagram. You can change the value of your resistor. So I change it to 0.5 kilo ohm, and also this resistor. And for the inductor, you can also change it, but I will just leave it to 1 millihenry. And for the step current, I change the final level to 10, and for the step time to 0, and for the rise and fall 0.1 nano. And then go to simulate and click analysis and simulation and go to transient. Then change the initial conditions to set to 0 and end time to 10 milliseconds. And go to output and let's check the current of the inductor. So press this variable and then run. So this is our transient analysis for the current of the inductor. So let's check if this is true. So first, calculate the time constant. So the formula is L over R. So our conductor is 1 millihenry. And then our resistor is 0.5 kilo ohm. So this is our time constant, which is 2 microseconds. And then let's calculate the 63.2% of the final current. So because in one time constant, the value of the current will be equal to the 63.2% of the final current. So let's check. So the 63.2% of our final current, which is 10, is 6.32. So let's check. Let's move our cursor to 2 microseconds. So as you can see, it is approximately equal. So in 2.0098 microseconds, the value of your current is 6.2756. And then our calculation is 6.32, so it is approximately equal. So this is true. In addition, let's check if 5 times the time constant, the resulting current will be more than 98% of the final current. So let's check. So 5 times our time constant is 10 microseconds, and 98% of our final current is 9.8. So let's check. Let's move our cursor to 10 microseconds. So as you can see, in 10 microseconds, the resulting current will be 9.9526. So it is more than 98% of the final current. So our calculation is correct.
Next, let's check the voltage of the capacitor. Go to Stimulate, then click Analysis and Stimulation. Choose Transient Analysis. Press Output. Add variable V2 and run the analysis. So, this is a transient analysis of the conductor voltage. So, let's check if this is true. Our time constant is 2 milliseconds. So, let's calculate the 36.8% of the initial voltage and compare it in the analysis. Since one time constant, the resulting voltage will be equal to 36.8% of the initial voltage. So, the resulting voltage is 1.840 kilovolts. Let's move the cursor and check if this is true. As you can see, it is approximately equal. So our calculation is correct. That will be all. Thank you for listening. We hope you learned something in this tutorial video.